Welcome back to The Explainer. Today, we're diving into the ultimate high-yield exam review covering the foundational, scientific, and technological breakthroughs of ancient India. Whether you've got an exam coming up or you just want to understand the profound roots of modern knowledge, you are in exactly the right place. Grab your notes, because we're going to make this highly structured, extremely efficient, and honestly, pretty mind-blowing.
So ask yourself this: what if the actual blueprints for modern science were written thousands of years ago? We tend to think of science as a strictly modern pursuit, right? But as we'll see today, some of the most critical concepts in astronomy, physics, and mathematics were actually solved millennia ago by ancient thinkers. This explainer is going to completely flip how you view the history of technology.
All right, here's our syllabus. We're covering 5 high-priority topics: astronomy and cosmic mechanics, mathematics, physics and the 5 elements, ancient tools and technology, and lastly, the pre-colonial trade empire. Let's jump right in.
Module 1, Astronomy and Cosmic Mechanics.
To really grasp early cosmic mechanics, we actually have to start in Mohenjo-daro. Archaeologists found these fascinating ringstones there, which were used to meticulously track sunrise times. And this obsession with timekeeping just evolved brilliantly over time. The early Rig Veda calendar conceptualized a 360-day year divided into 12 parts. But then, the later Yajud Veda calendar made this massive, absolutely game-changing scientific leap. It successfully recognized and integrated both a lunar year of 354 days and a solar year of 365 days, splitting the year into 6 seasons of 2 months each. Definitely highlight this level of precise calendar calculation. It's an absolute must-know for your exam.
Okay, look, if you only memorize one historical figure from today's review, it has to be Aryabhata. He wrote a wildly concise text called the Aryabhatiya, containing exactly 121 verses, no fluff. And he didn't just passively observe the night sky, he figured out the actual mechanics behind it. Without a single modern telescope, he correctly proposed that the Earth rotates on its axis. He calculated the true positions of the planets. And honestly, most impressively, he laid out the exact scientific mechanics behind solar and lunar eclipses. He literally laid the groundwork for modern astrophysics right there.
Moving on to Unit 2, Mathematics, Shaping Modern Science. So the whole mathematical foundation for modern computing actually kicked off with texts like the Sulba Sutras. They used practical geometry to construct incredibly precise fire altars. But they didn't stop there. They pushed way past practical construction straight into highly abstract mathematical theory. Take the concept of zero, for example. It is literally impossible to overstate the monumental importance of this breakthrough. Ancient thinkers in India didn't just use a blank space as a placeholder. No, they conceptualized zero as an actual number with its own strict mathematical properties. That single philosophical and mathematical leap, it's the absolute bedrock of our modern decimal place value system.
Let's connect the dots between these ancient giants and their modern scientific legacies. First up, Aryabhata again, formulating the area of a triangle, diving into advanced algebra, and calculating a remarkably accurate value for pi. Then we've got Brahmagupta. He formally wrote the actual rulebook for zero, plus operations for positive and negative numbers. And finally, Bhaskara II. His incredible work laid down early conceptual frameworks that heavily resemble modern calculus, centuries before it emerged in Europe. Take a mental snapshot of these brilliant minds right now.
All right, Unit 3, Physics, the 5 elements.
Now, how did the ancient world understand energy, the physical universe, and the very nature of matter way before we had particle accelerators? Well, the foundational concept comes from Vedic times, specifically categorized by the Vaisheshika school. They classified the entire material world into 5 core elements: earth, fire, air, water, and ether, or space. The central belief was that every single physical object out there is constructed from a specific combination of these fundamental elements, and upon its ultimate destruction, it just returns directly back to them.
Which brilliantly brings us to our next massive exam takeaway. The philosopher Kannada proposed a concept called Anu. He defined Anu as the absolute smallest, indivisible particle of matter. Just think about that for a second. Thousands of years before modern atomic theory, they were fundamentally conceptualizing absolute, indivisible particles and molecular structure. It was an astonishing abstract philosophical understanding of atomic division that perfectly predicted the core concepts of modern physics.
Next up, Unit 4, Ancient Tools and Technology.
Let's take a look at how these scientists practically engineered their world. Imagine being a scholar in ancient North India. The evolution of writing technology alone is such a fascinating story. Early on, records were meticulously inscribed on birch bark, using the super durable specialized ink synthesized from charcoal, gum, and oil lamp soot. Over the centuries, that practice evolved into incising letters onto palm leaves with sharp points, then rubbing charcoal powder into the cuts to make them visible. Finally, by the 15th century, artisans in Kashmir were engineering world-renowned, high-quality paper out of rags and hemp. They weren't just writing, they were deliberately engineering the preservation of human knowledge.
Make sure to highlight this next term in your notes, the Harappan-Builder ratio. The Indus Valley civilization didn't just casually throw up cities. They rigorously standardized them. They used a strict 1 to 2 to 4 ratio for their fired bricks. That's height to width to length. This specific proportion wasn't just random either. It was a practical application of geometry, deliberately designed to maximize structural integrity and create incredibly strong, enduring walls. It is a perfect early example of applied mathematics in urban engineering.
And the leap in ancient metallurgy and chemistry? Just as profound. We now know from recent excavations that iron was being successfully produced in the Ganga Valley as early as 1800 BCE. By the 1st century CE, we're seeing mass production of metals and advanced alloys like bronze and brass. Pulling that off required immense temperature control and a deep understanding of chemical properties, showing true scientific mastery. Fast forward to the 16th century, and this chemical expertise had evolved into sophisticated pyrotechnics, literally utilizing gunpowder and early rockets in warfare. Going from basic iron smelting to advanced rocketry is a serious testament to thousands of years of scientific refinement.
Finally, Unit 5, the pre-colonial trade empire.
So how did all this immense scientific and technological dominance actually translate into real-world macro power? Well, look at the economic reality 2,000 years ago. India and China collectively controlled 60% of the global GDP. Yeah, 60%. That staggering figure wasn't just some accident of geography. This immense wealth was the direct, undeniable result of their advanced infrastructure, mathematically optimized agricultural yields, and completely unmatched manufacturing technologies.
All that wealth was driven by high-yield exports that the rest of the world desperately wanted, but just didn't have the technology to replicate. They maintained a massively favorable trade balance by exporting incredibly high-quality wood steel, which, by the way, was acquired to forge those famous Damascus swords. They also exported beautifully dyed cotton textiles like muslin and calico, utilizing advanced organic chemistry for their dyes. Plus, they were shipping out precious stones, ivory, and heavily demanded spices to Europe, West Asia, and Africa. Because of this unparalleled supply and demand dynamic, fueled by pure technological superiority, India accumulated massive gold reserves, earning the title of the global golden bird.
As we wrap up this explainer, I want to leave you with a final thought. How wildly different would our modern scientific and technological landscape look without these ancient foundations? From the profound mathematical concept of zero to philosophical atomic theory, from standardized urban engineering to global trade networks fueled by metallurgical mastery, the ancient Indian civilization didn't just participate in history, they fundamentally engineered the foundations of the modern world. Keep these key concepts front and center for your exam, and remember the massive legacy behind the facts. Thanks for joining me, and we'll catch you next time.